So, good morning, students. So, yesterday we have discussed about the probability, sample space, events, axioms of probability as and the properties, conditional probabilities, and Bayes theorem independent event. So, today we will talk about. So, let me start. So, today, 1 minute. Today topics we will discuss are random variables, probability distributions, expectation, variance, higher order moments, and function of variables. Okay. Then after, yeah, today we are discussing these 6 topics, and this is quite easy, but most it is conceptual topic. Like you have to clear your concept in this because these are the foundation of the statistics. Because mostly questions were asked from the random variables, probability distribution, expectations. Okay, so we will start with random variables. So let's start. Random variable. So what is random variable? So when you say that let's toss a coin, okay, let's toss a coin. Suppose let toss a unbiased coin. Okay. So what is random variable? So random variable will be x is equal to head, tail. So these are the random variables. Okay. So random variables is not like a random number. Okay. It is random variables. So definition of random variable is so a random variable is uh, random variable is a function denoted by x omega with domain, sample space, and range minus infinity to infinity, such that for every real number a, the event omega x omega is less than a belongs to b. Okay. So what is b here? B here is nothing but it is the alpha field. B is alpha field of subset of sample space. So the definition is not important for the jam topic. I just here write it down so that you know the definition. Okay. Okay. So how will you write? Suppose you given that probability of x is less than a. So you will write it that probability omega given x omega is less than a. Okay. And how will you write probability of x is equal to x? That is equal to probability omega x omega is equal to x. So this is the way to write the random variable. Okay. Yes, for example, let me take one more example. Suppose an experiment consists of rolling a die and reading of points, numbers on the upturned face. So random variable x is what? So uh, random variable x is equal to omega, where omega is 1, 2, 3, 4, 5, 6. Okay. Now there are some important theorems of the random variables. You just remember this. You don't need to go to the proof of this. Theorems of random variable. Now, first, sorry, first. So first is what? Now, a function x omega from sample space to R minus infinity infinity is a random variable if and only if omega x omega is A belong to B, where B is the alpha field of the subset of the sample space. It is a first thing. Like what is x? Suppose that we are giving a number. Then how will you prove that it is a random variable? For that we will need to prove this. And the proof is not important for the jam point, but this is a way to prove. No, second. If x1 and x2 are random variables and c is constant. Suppose c is any number and it is constant. Then cx1, x1 plus x2, x1, x2 are also random variable. Suppose x1 is equal to 5 and c is equal to 2. Then cx1 that is equal to 10. It is also a random variable. Okay. Now third, if x is a random variable, then 1 by x, where 1 by x into omega is equal to infinity, if x omega is equal to 0, is a random variable. Okay. Second is x plus omega, that is equal to max of 0 x omega, it is also a random variable. X minimum omega, that is minimum of 0 x omega, it is also a random variable. Okay. Now two more important properties, that is if x is a random variable and f is a function and this function is a continuous function. And I suppose that you know about the continuous function, discontinuous function, differential. Okay, continuous function. Then fx is random variable, and if x is a random variable and f star is an increasing function, then fx is also a random variable. So if the function is x is a random variable and there is a function which is continuous function, then that is also a random variable. If x is a random variable and fx is an increasing function, then fx is also a random variable. We will see some of the examples in the upcoming lectures. Okay. Now this another important concept, that is distribution function. Distribution function. Okay. So what is distribution function? So let me change. Let x be a random variable on the What is this? This is the probability space because is the sample space, sigma field, and the probability measure. If x is a random variable, then the distribution function is defined as probability of x is less than x, that is equal to probability of omega x omega is less than x, where x is minus infinity is infinity. So this is the distribution function. So there are some of it is also known as cumulative distribution function. Now, properties of distribution function. See, the properties are important because sometimes you get a direct question from the properties of distribution function in the gen. Okay, so property one is what? If f is the distribution function, I am using df of the random variable rv for the random variable x, and if a is less than b, then probability of a given x is given b is equal to probability of fb minus probability of a. And I'm not giving the proof of these because the proof is not important, but if you want, then you should use book like Fundamental of Mathematical Statistics for the proof. Okay, probability of property 2 is that probability of a given x given b is nothing but probability of px is equal to a plus fb minus fa. And what is px is equal to a? So px is equal to a is nothing but probability of a minus probability of a minus. What is a minus? A minus is just the function above the a. For example, this is because x is equal to a here. So E8 minus that before that function, that is this. Okay. So the formula become fa minus fa minus plus fb minus fa. So this fa and this fa cancels. So it becomes fb minus fa minus. Don't worry, we will see some of the examples below, so you can clear about this formula. Okay. Then here the property 3. Sorry, probability of a is given x is given b. Sorry, not given. Probability of a is less than x is greater than b. That is probability of a given x is given b minus probability of x is equal to b. Okay. So what is this? Probability of b minus probability of a minus probability of x is equal to b. Oh, it can be written as fb minus fa minus fb minus fb minus. Okay, then this is cut out, then equal to fb minus fa. So this is the property for 3. Then after property 4, that is probability of a is less than x is less than b, that is equal to probability of a b plus probability of x is equal to a. How can we write this? We can write this as probability of fb minus probability of a minus probability x is equal to b, probability of x is equal to a. So this is the formula. Now another property is that if f is a distribution function of one dimensional random variable x, then fx. So this fx is always between the 0 and 1. Yeah, it is a very important concept because the distribution function range is always between 0 to 1. Its minimum point should be 0 and maximum should be -1. It doesn't go beyond the 1. And the second property is if fx is less than fy if x is less than y. Okay. And the sixth property is if f is a distribution function of one dimensional random variable x, then if the distribution function at minus infinity should be 0 and distribution function at infinity is equal to 1. So whenever you in a distribution function you put minus infinity, it will go to 0 because its range is between uh, because range is between 0 to 1, and whenever you put the infinity it will equal to 1. Okay, now we have sorry, let me then we have discrete random variables. So what is discrete random variables? So discrete random variables are 1 minute. So discrete random variables are those which take at a most countable number of values. Okay. Countable means 1, 2, 3, 4, 5, not 1.5, 1.6. Okay. So let me define this. If a random variable takes at most a countable number of values, it is called discrete random variables. Okay, so in the discrete random variables, there is a concept called probability mass function. Okay, so what is probability mass function? So probability mass function is a probability distribution of the discrete random variables. It is what? Probability distribution of a discrete random variables. So it satisfies two conditions. First of all, is that probability of x should be greater than 0 and summation of probability of xi should be equal to 1. Now, so what are the discrete distribution functions? Because the probability mass function is defined only for the discrete random variables or discrete distribution functions. So some of the discrete distribution functions are Bernoulli distribution, binomial distribution, Poisson distribution, then after geometric distribution, hypergeometric distribution, negative binomial, distribution. So it is there is much more, but for the jam perspective, only Bernoulli, binomial, Poisson, geometric are quite important. Okay. Then here is the uh, okay. Let me go for the continuous part. So we have continuous random variable. So continuous random variables. So what is continuous random variable? So a random variable is said to be continuous if we take all possible values between the certain limits, like say from 1 to 2. It will take every point 1.5, 1.55, 1.555, 1.555555. Okay, so this is denoted by the continuous random variable. So let me define a random variable x is said to be continuous if it takes all possible values between certain limits. Okay, so this is the definition of the uh, continuous probability distribution function. So like here in the discrete random variables, we have the probability mass function. Similarly, in the continuous random variable, we have a probability density function. Why we call it density? Because it takes the continuous variable that we are talking about, the density function. Okay. So what is the probability density function define the probability define the probability distribution of continuous random variables. Okay, suppose like this. So these are some of the continuous distribution function. So you have to calculate the probability of this. That is a b. So how will you define probability of a is x is b. So we will take the help of integration. This is your continuous random variable, and this is your dx. So how you this by this way you will define the by this way you will define the probability of distribution of the continuous random variable. Okay, so it is given that fx is equal to limit that x tends to 0. Probability of x is given that x plus delta x divided by t delta x. Okay, so this is the about the continuous random variable. So some of the point like arithmetic mean, harmonic mean, you should know about it. But yeah, it's that. Now various measures of central tendency. Okay. So what is central tendency? Central tendency means that 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 measures gives the idea about the middle point of the distribution. For example, mean gives the average, median gives the middlemost point, mode is the number of frequent variable that come most frequent. Okay. So suppose let fx be the PDF of the random variable x, or x is defined from A to B. So the first is arithmetic mean. I am written as AM. How will you calculate BA x into fx dx? It is also known as expectation. I should write down also known as expectation. We will see about the expectations in the upcoming lectures. Okay. Then the second is harmonic mean. Harmonic mean that is equal to 1 upon h b a 1 upon x into fx dx. Then after the geometric mean, it should be defined by log g a log fx dx. You should get the log to that side, then you will get the g. Then the fourth is mu r dash r about origin. How should we define this? Will be a is equal to, sorry, xr into fx dx. And what about the point? If mu dash r about some different point x is equal to a, then it will be equal to b a x minus a r to fx dx. Now about mean mu r, that is equal to b a x minus mean r fx dx. Now, how will you define the mean from here? So, from these, this is so important. You should remember this is important. Okay. See how mu one dash. It is nothing but it is a mean. Okay. So it is defined as b a x fx dx. Because just compare this into and this, you will say this is same. So this is when mean. And what is mu two dash is equal to b a x square fx dx. It is the second moment. It is what we call, it is called second moment. It is the first moment. Okay. Then from this we will calculate the variance, that is variance of x, or the variance should be defined as mu2. Why mu2? Because mu2 is about mean. See here, mu2 is about mean. So you will define as, oh sorry, mu2 dash minus mu1 squared, that is equal to b a x squared fx dx minus bracket b a fx and x dx ka square. What is this? This is variance. So this is mean, this is variance. That's why the moment is important. Okay. So similarly, we will define the third moment. Say mu3 is equal to mu3 dash. It is the third moment about mean minus 3 mu2 dash 3 mu1 plus 2 mu1 3. Okay. Then after we have median. Median is what? So we will define the median by m into a into fx dx is equal to b into m into fx dx is equal to 1 by 2. Why 1 by 2? Because the median divides the data point into half. Suppose that this is our sum of the data. Okay. So what is median? This is the median because it divides this part and this part with equal probability, 1 by half and 1 by half. So that's why median is defined by this. Okay. Then after mean deviation, mean deviation is what? It is equal to m a. Sorry, mean deviation is equal to b a x minus mean into fx dx. It is the mean deviation because it is deviated from the mean. Okay. Then we have quartiles. These concepts you have learned in your bachelor's, but so this is only a recall, like recall class, because I just recall all the formula. So Q1 and Q3 are, what is Q1? Q1 is the first quarter and Q2 is the third quarter. So Q1 is equal to 1 by 4 Q3 a fx is equal to 3 by 4. So why it is equal? Because suppose this is your data. Okay. So this is median and Q2 is here. Q2 is nothing but it is a median. It divides because this is Q2 because it divides the data into the half half. This is Q1 because it divides the data into 1 by 4, 1 by 4. This is Q3. It divides the data into another 1 by 4, 1 by 4. So Q1 is from where? Q1 is from this Q. This is Q1. This is okay. This is Q1. Let me change the color. Now this is Q2. Okay. And this is Q3. That's why it is 3 by 4 and it is 1 by 4. Okay. So I hope you understand what is the what is the quartile and dectile means. Yeah, sorry. So dectile. Dectile is that which divide the data into the 10 part. 10 part means di into a fx dx is equal to I by 10. So what does this dectile do? So this is your data. It is your Q2. So the Q1 is this. 1 to, sorry, uh, this is 1 by 10 part. This is Q5, Q2. So it divides the data into the 10 equal part. That is called dictile. And then you have to calculate the mode. So mode is the most frequency value. Okay. So let's do some of the examples to understand the concept better. Okay. So example one. So what is example one? Suppose the diameter of an electric cable, say X, is assumed to be a continuous random variable with PDF. See, the PDF is given here 6x into 1 minus x. And here is a range. See, in statistics, whenever you solve the question of probability, please specify the range. Because if this range is not specified, then your probability density function is not defined. Okay. Now the first question is mine. Check the above is PDF. Now, and second is determine A and B such that probability of x is less than b is equal to probability of x is greater than b. Now, this is a very good question. See, suppose I have given some of the functions, say fx is equal to x. Then how will you define that it is a PDF? Because you don't sit and just start the proving what is sigma field is. Okay. So I show how you will do this. Okay. So whenever you have to check the given function is probability density function, you just have to prove one that if integration of this from b to a dx is equal to 1, it is a valid probability density function. Important, I should make the box. Okay. See, whenever you solve the questions, you will get to know more concepts because it is not possible that I taught you all the concepts. But when you start to solve more and more questions, you will come to know that how this little concept is very important for the examination purpose. Okay. So whenever you do the integration of the fx from its given ranges and it equal to 1, it is a valid probability function. For example, here fx is what? Here fx is 6x into 1 minus x. And what is b here? The b here is 1 and a here is 0. So just take the integration 1, 0, 6x into 1 minus x dx. So, so you should know about the integrations. You have taught mathematics like differential mathematics and integral mathematics in your bachelor's. So 6x minus 6x square integration 10 dx, break it 6x 10 dx minus 106x square dx, that is equal to 6x square by 2 minus 6a cube by 3, 1010. Now put here, cut 3x square 10 minus 2x cube 10, put it here. So 3. If you put here 1 is 3 minus 2, that is equal to 1. So it's coming 1. So the given function is a valid probability density function. Okay. So the given PDF is valid. Okay. Now, what is the second part? It is saying second part is saying determine A and B such that probability of X is less than B is equal to probability of X is greater than B. So how will you do this? Nothing but B is equal to probability of X is greater than B. Okay. So just start doing. See, this is upper bound B0 fx dx is equal to. Now it is maximum. So probability should not go beyond 1. So what is the maximum range? So maximum range is 1 and the minimum is b. Because say probability of x is b, you will have to write like this. 0. So when probability of x is b, you have to write it 1b, or you should write 1 minus probability of x is less than b. So you can also write by this. Okay, so these are two ways, fx dx. So take the 6 common, we have b0 x into 1 minus x dx is equal to 6 common 1b x into 1 minus x dx. 6 and 6 can be cancelled out. So what is the integration? X squared by 2 minus x3 by 3. Just add b0. Same here, x squared by 2 minus x3 by 3, 1b. Okay. So when you solve this, because I don't solve it here, I just write the direct 3b squared minus 2bq is equal to 1 minus 3b squared plus 2bq. Okay. So what is equal to 4b cube minus 6b squared plus 1 is equal to 0. So this is a quadratic equation. Just solve 2b minus 1 into 2b squared minus 2b minus 1 is equal to 0. So we will be what is equal to 2b minus 1 is equal to 0 and 2 or 2b squared minus 2b minus 1 is equal to 0. So b is equal to 1 by 2. So you get the value of b because it is satisfied between the 0 and 1. Okay. Okay, so I think we should do one more question that is important. Okay, so I will give you. Okay, this is an important example. You will learn a more concept in this question. Suppose a probability curve. A probability curve y is equal to fx has. Now from this time I will write the question from the black and solve the solution in blue. Okay, from 0 to infinity. So it is given that range is from 0 to infinity. Okay, always remember, read the question properly, see what is the range given and what is your PDF. Okay, so if fx is equal to e to the power minus x, so this is your PDF. It is an exponential function. Find the mean, find the mean, variance and third order moment. Third moment about mean. Okay, so what is about mean? So about mean means this is your mu1 dash, this is your mu2, sorry mu2, and it is your mu3. See here, I just not put it. Hold on, I just erase it. Huh. In mu1 we have put it the one in the above because it is about, it is to show that it is a from origin. But in variance it is about mean, so I don't have to put the one above. Okay. So start calculating the calculating. Okay. So solution. Given PDF fx is equal to ex. Now if I am asked that it is a valid probability density function, so what do we have to do? Just give the integral fx dx is equal to 1. So just put 0 e to the power minus x dx. So its integration is what? Minus infinity 0. So what is, if we put the infinity to 0 minus, if we put the to minus 1, that is equal to 1. So it is a valid integration function. So now we have to calculate mu r. Mu r a means infinity 0 x r fx dx. Okay, so just put 0 x r into e to the power minus x dx. Now what is this? So this is a gamma integral. What is this? This is a gamma integral. So whenever you get the questions of like this, you use the gamma integral, that is gamma r plus 1 is equal to r factorial. Okay, so this is equal to, answer is r factorial. Now just put r is equal to 1 here. It is a general formula. Just put r is equal to 1, you will get the answer. Mu 1 1, that is 1 factorial. factor is nothing but 1. So the mean is 1. I just mark in red box so that you remember this gamma integral. Okay. So what about the mean variance? So variance is sorry. Variance is mu2 minus mu1 ka whole square. So what is mu2? Mu2 here is 2 factorial, that is equal to 2 into 1, that is 2. Okay. So variance is 2 minus 1 square, that is equal to 2. Sorry, that is 1. Okay. So variance is 1 and mu3 is equal to mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash 3. So calculate mu3. Mu3 is equal to 3 integral, that is 6, because 3 into 2 into 1 is equal to 6. Okay, just put the value 3. 1 minute. 6. 6 minus 3 into what is mu2 here? My mu2 is 2 into 1 plus 2 into 1, because if you take the cube of 1 it is 1. 6 minus 6 plus 2, that is equal to 2. So mu3 is 2. You see how questions taught you a new, each question taught you a new concept. Okay. So I think this is enough. And now let's see the syllabus. So what is left? 1 minute. Yeah. So we have completed the random variable, probability distribution, expectation, variance, higher order moments, function of random variables. So let's go to the topic of expectation, or I think I should solve you some more questions. Um, okay, let's see. Yeah, one more problem I think I should left to taught you, that is continuous distribution function. Yes, I just remember. Sorry, just I left important thing, that is continuous distribution function. Okay, so what is continuous distribution function? So a continuous distribution function is defined as, suppose if x is a continuous random variable with PDF, fx is, then the continuous random variable is defined as probability of x is less than x is equal to x minus infinity ft dt. Now the question should be like, why should I take minus infinity? Because you have known that when I taught you the distribution function, and I said you that property f minus infinity is equal to 0. So whenever you put the minus infinity, the function is automatically equal to 0. Okay. Now there is some important points that I have to discuss. First is same fx should lie between 0 and 1. Okay. The second is, if you have the fx, like if fx is given, how we will calculate fx. So for fx, nothing but take the differentiation of this. Okay, and when you have fx, so or when you have fx is given, f cumulative distribution function is the integration of fx into x. This is important. Okay, So whenever you given the fx, just take the differentiation of your cumulative distribution functions, you will get your fx. Or whenever your fx is given, take the integration of the fx so that you will get the fx. Sorry, this is the CDF. Sorry. Yeah, this is your CDF and this is your PDF. So it is a relation between the CDF and the PDF. Okay. Okay. So this is what I have. Why not we solve one of the questions so that we get the concept more clear? Okay. So the example 3. Verify that following distribution function fx is equal to 0, 1 by 2 into x by a plus 1 minus a given x is equal to a, x is less than is equal to a and 1. Yeah. Okay. So we have to verify that this function is a proper CDF. Okay. I will choose blue for solution. So what we have to do? So we have to satisfy property 1, property 2, property 3, and property 4, which I have discussed earlier. So first of all, calculate the fx. So how will you calculate the fx? Take the differentiation of this. So 1 by 2 into differentiation of x by a plus 1, that is what? 1 by 2, it is 1 by a plus 0. So fx is 1 by 2a when minus a given, sorry, minus a is less than x is greater than a and 0 otherwise. Means, what does it mean? It means that probability density function is valid only in these interval and 0 otherwise. Means if the solution is between these interval, like any solution between minus a and a, then this PDF is valid, otherwise it will 0. Okay, now we have to check. Okay, now just minus infinity to minus infinity fx is equal to dx is equal to 1. So take the integration between a and minus a of 1 by 2 a dx. It is 1, so it is a valid CDF. So we have not proved it from the properties of P1, P2, P3, P4, but we have just taken it like it is easy, because in examination you don't have enough time to just take prove all the properties and then satisfy them, told that this is a valid CDF. Instead of that, what you should do, you should take the differentiation of the cumulative distribution function and just show that it is a valid CDF. Then it is also good. Okay. Okay, let me see some more questions. I will suggest you to please solve more and more questions. That is good, because by solving more and more questions, you can clear your more concept. Now we will see another topic, that is joint probability law. Okay, so by now we have only taken a one random variable, say x. But from now we have to take two random variables, say x and y. Okay, so when they are joint probability law, so see two random variables x and y are said to be jointly distributed if they are defined on the same probability space. Okay, if the both are jointly distributed only if they are defined on a same probability space. If they are not defined on a same probability space, then it is not the joint probability law. How will you define it, or how will you write it? You will write like this: Pxy, where probability of xy belong to E, where E is a certain event. E is certain event. Okay. Now some another concept is here, that is joint probability mass function. Because our we have learned about the probability mass function, but here we have to learn about the joint probability mass function. So how will you define the joint probability mass function? So the joint probability mass function is defined by, suppose x is our random variable, sorry, with sample space, and y is another random variable with sample space, that is equal to x1 x2 dot xn into y1 dot y. So probability of ij is equal to probability of x belong to, sorry, equal to xi given y is equal to y, which is common because it is a joint probability space, joint probability distribution only when both satisfy the same probability space. That's why we have to say the intersection. Intersection means that both have the common probability space, and you can write it like this: xi yj. Okay, and how will you write in a table? So I write in a form of table, that is x, this is y, this is y1 y2 x1 x2, it is p11 p12 p21 p22. What it means? It is p1, it is p2, it is p dot 1, it is p dot 2. Okay, now what is marginal? Marginal means, okay, let me write it down. So marginal probability, oh, sorry, yeah, I'm sorry, just by hand I just, marginal probability function of x. Okay, so how will you write? So see, what is the marginal probability? So I just explain you with the help of table, you will better understand. See, this is y1 y2 y3 y4, that is x1 x2 x3 x4. Okay, p11 p12 p13 p14, sorry, 314. Okay, so this is p1, this is p1. So what is this? So this is, sorry. So this is the marginal of px1, and this is the marginal of py. Okay, so p1 is a marginal probability function of x. Same for p2, p3, p4, and it is the marginal probability of y. Same for this. Okay, so this is the marginal property. How will you define? So we will define like this: marginal probability function of x is sigma n I is equal to 1, pi is equal to p1 dot plus p2 dot plus pn dot. Okay, so this is the margin. Just in sum of these is marginal, like sum of p11 plus p12 plus p13 plus p14 equal to p1, that is the marginal of x. Same for the marginal of y. And how will you define the conditional probability function? So conditional probability function. So the conditional probability function is defined as probability of y is equal to yi given x is equal to xi, that is equal to probability of xi yi given probability of yi. Sorry, probability of xi. So this is a conditional distribution function. Same that we have taught it, but instead of a and b, we have the two random variables y and x. Okay. Now we have the concept of joint probability distribution function. So what is joint probability distribution function? So the joint probability distribution function can be written as fxy x y, that is probability of x, sorry, probability of minus infinity x is less than x and minus infinity y is less than y. Okay, so we can write in a form of integration minus infinity given y minus infinity fxy into xy dx dy. Okay, where fxy is greater than 0. Okay, just I have written, yeah. So this is a discrete random variable. So for continuous, we write like this fxy. This is a continuous two-dimensional random variable. Okay. So this is for the distribution function, like joint distribution function. Instead of when we talk about it is for continuous, for discrete, we have xy is equal to sigma x is equal to minus infinity, sigma y is equal to minus infinity, pxy xy. Okay, instead of dxy dfy, we use, instead of, sorry, integration, we have to use the sigma. So here I should use the red for the heading. Marginal distribution function. So what is marginal distribution function? Okay, so when you have the x and y, and from this we have to calculate fx or fy. So this fx and fy are called marginal distribution function. Okay, so how will you calculate? So probability, sorry, the distribution function of x can be written as probability of x less than x1, that we have seen in the previous class. The probability of x is less than x into y is less than infinity. So one point is must remember. Suppose we have to calculate for x, then put the y is less than infinity. This will what will lead? It will lead to limit y tends to be infinity fxy to xy. Okay, so you can write it like this: x infinity. Same when you have for you have to calculate for y, that is probability of y is less than y. You have to write like this: x is less than infinity, y is less than y. That is equal to limit x is less than x goes to infinity fxy xy. That is equal to fxy infinity y. So this is the way to write the marginal distribution function. Okay. Or in a case of, now in case of discrete. So how will you write in a case of the discrete random variables? So in the case of discrete random variables, fx is equal to whole y, probability of x is less than x, and y is equal to y, or fyy is equal to x, x and y is less than y. Okay. Now, in a case of joint continuous random variable. So in a case of joint continuous random variable, fx is written as x minus infinity, infinity minus infinity. See, in when we have to differentiate with y, sorry, integrate with y, we have to take both the infinity minus infinity. And when we have this y minus infinity, infinity minus infinity, put the bracket fxy dx into dy. So this is the marginal of fx and fy. Okay. Let me illustrate with one example so that the concepts are, more understandable to you all. Okay. So let me see one question. Yeah, I think this is perfect question. Example 4, I think it is. So for the following bivariate, see sometimes normal jointly distribution is also written as a bivariate, so don't confuse. Bivariate means two variate. Probability distribution of x and y. For the following bivariate probability distribution of x and y, calculate probability of x is less than 1, y is equal to 2. Second, probability of x is less than 1. Third is probability of y is equal to 3. Fourth is probability of y is less than 3. And fifth is probability of x is less than 3, y is less than 4. Okay. So what is the table? So let me draw a table. See, by solving examples, the concepts will more clear to all. 1, 2, 3, 4, 5, 6. Okay. These are the value of y. Okay. Now for value of x, we have 0, 1, and 0, 0, 1 by 32, 2 by 32, 2 by 32, 3 by 32, 1 by 16, 1 by 32. Okay. 1 by 16, 1 by 32, 1 by 8, 1 by 64, 1 by 8, 1 by 64, 1 by 8, 0, 1 by 8, 2 by 64. Okay, so these are the questions. So first of all, it is so whenever you get this question, I would like to write that first of all solve the um, marginal probability. Okay, see, okay. So what is the probability of Px is equal to 0? It is nothing but add all this. Sorry. Add all this. So probability of x is equal to 0 is 0 plus 0 plus 1 by 32 plus 2 by 32 plus 2 by 32 plus 3 by 32. That is equal to 8 by 32. So what is this? 8 by 32. Hmm. 1 minute. I just erase it because I don't get the place to write the marginal of the y. That's why it's very easy to 0 plus 0 plus 1 by 32 plus 2 by 32 plus 2 by 32 plus 3 by 32. It is equal to 8 by 32. Same for probability of x is equal to 1, add 1 by 16 plus 1 by 16 plus 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8, and that will get you 10 by 16. So it is equal to 10 by 16. Similarly for this, you will get 8 for 64. Now for calculating the marginal of y is equal to 1, do 0 plus 1 by 16 plus 1 by 32. That will equal to 3 by 32. So it is 3 by 32. It is 3 by 32. Just add the individuals. I should highlight for this. Um, you will get 11 by 64 for this, 13 by 64 for this, 6 by 32, and 16 by 64. And one more important concept here. Whenever, no, how will you know that this is correct? Like when sometimes it is quite possible that the summation would be wrong. So whenever you do this, the summation of all these and all this should be equal to 1. Okay. So whenever you add these and whenever you add these, it's all equal to its solution will be 1. Okay. That is mean this means summation of all px is equal to 1, summation of all y is equal to 1. So like 18, like it is 26 and it is what? 3 plus 3, 6 plus 17, 17 plus 3. Okay, yeah, it is correct. Now, what is the second question? Second question is that, sorry, first question is that probability of x is less than 1 and y is equal to 2. So it is equal to probability of x is equal to 0, y is equal to 2 plus probability of x is equal to 1, y is equal to 2. So what is probability of x0 and y2? So x0, y2 is nothing but 0 plus x1 and y2 is 1 by 16. That is equal to 1 by 16. It is your answer. See, the easy questions are there. Okay. Now the second is probability of x is less than or equal to 1. What does it mean? It means probability of x is equal to 0 plus probability of x is equal to 1. So what is probability of x? 0. Probability x is equal to 0 is 8 by 32. 8 by 32. And what about the 1? That is 10 by 16. After solving this, you will get 7 by 8. Okay. Now the third is what is third? Probability y is equal to 3. So what is y is equal to 3? See, probability y is equal to 3 is 11 by 64. Just write it down 11 by 64. Round. And this is 4. Probability of y is less than 3. What does it mean? It means y is equal to 1 plus y is equal to 2 plus y is equal to 3. Just look the value from the tables and put it down. 3 by 32 plus 3 by 32 plus 11 by 64, that is 23 by 64. So these are the answers of your questions. Okay. So from the next class, I will give you some of the questions for the practice as well. Okay. So this is uh, now I just one concept is left, that is expectation. I think I should complete in this lecture so that because the jam examination time is not much more. So I think I should complete this lecture. So let me start. It is very like it is 5 to 10 minute topic because you don't need to be get into the deep like what is expectation and what is you know so I think I should complete this so that you can get the time to revise as well. Okay. So let me start. And it is not a big topic. It is a very small topic. There is 2 to 3 important formula that you get to know. And then after, it is easy. Okay. Okay. Let me start. Expectation and variance. Okay, so this is important topic. See, in expectation and variance, there is a concept of moment generating function, then probability generating function, and characteristics function. But these topics are not included in the JAM syllabus. So I suppose that these topics were not. And when I see the previous year papers, there is no questions from these topics. Okay, so that's why I suppose that the question from the expectation and variance are asked. Okay, so let me start. So expectation. So what is expectation? See, in expectation, it's just a mean. Mean key, what is your expected value? Okay. So its formula is written as Ex is nothing for, okay, 1 minute. I'm not like this. Okay, 1 minute, why it cause me problem? I have to see. Yeah, it's for, yeah. Okay. So for discrete distribution function, expectation is defined as x px dx. Okay. So for the discrete problem where x is a loop, let me like this. This is, sorry for disturbance. Let me write like this. Yeah. Let x be a random variable so that, see, proper definition will help you to understand concept more well. X, sorry, random variable with PMF slash PDF as fx. Okay, then expectations can be defined as infinity minus infinity x fx dx for continuous random variable and sigma x px dx for discrete random variable. Okay, so this is the concept of expectation. And how will you define the variance? So variance is defined as nothing but x squared minus इसका whole square. So what is this? What is this x square? So x square can be calculated as infinity minus infinity x squared fx dx for continuous, or x squared px, sorry, I just written here the dx, that is not correct. Sorry for my mistakes. That is discrete random variable, continuous random variable. Okay. Now, now suppose considered the random variable x with PDF or PMF and distribution function fx. Okay, and let g is a function such that gx is a random variable. So g is a function such that when you put the, like, if any function is defined, then gx is also the random variable. Then the expectation of gx is nothing but dx for continuous and sigma gx px for discrete. This is another important concept. Okay. Now, how will you define the variance? So variances can also be defined like this. Variance is also defined like sometimes in examination they will ask question like this. So this is also a variance. Okay. Now there is some of the theorems on the expectation. So I just write the theorems because you don't need a proof of that, and it is very easy theorems. Okay. So theorem one is what? If x and because theorems are important while solving the problems. Random variables, then expectation of x plus y is equal to expectation of x plus expectation of y. So this is the first theorem. Second is theorem 2. If x1, x2 dot xn are random variables, then expectation of x1 plus x2 plus xn is equal to expectation of x1 plus expectation of x2 plus expectation of x. Okay, this is your second. So what do you mean? If we have the 100 expectation, 100 random variables, so will you, if each individual expectation is given, just and you have to take the whole expectation, just take the sum of the individual expectations. Okay. Now, three. If x and y are independent random variables, okay, then expectation of xy is equal to expectation of x into expectation of y. So when x and y are independent, then this condition is satisfied. But if x and y are not independent, then you have to calculate like this. X, y, 1 minute. If they are not independent, then you have to calculate like this. Xy, xy, dx, dy. Like you have to integrate first of all for the x and then for the y. Okay. Same. This is third. If x1, x2 are xn independent random variable, then expectation of x1 xn is equal to multiplication of all individual xi's. Okay. Then important property. Oh, sorry. What is now? If x is a random variable, I'm sorry that the class is too long, but these are easy concepts. Now, if it take time, then it is not good for your preparation. A is constant, then expectation of A is equal to where y-x is function. What does it mean? So suppose x, we have to find the expectation of this, and a is a constant. Constant means a is number 4, 2, 3, 5, 6. Just then take the a out from there, and you get the expectation and calculate the ex and then multiply with a. Okay. And then when you have like this, a plus, then it is equal to a plus, because the expectation of the constant is constant. Okay. Okay. One important property. Expectation of 1 by x is not equal to, because many students understand that if it is conditioned that if 1 by x is given, then we should write 1 divided by 1 by expectation. That is not valid. Okay. Second, expectation of x 1 by 2 is not equal to expectation of x, and you don't take the 1 by 2. Okay, like if you have to take out the expectation of under root 2 under root x, then it is not equal that if you take the expectation of x and then calculate the under root 2. No, it is not equal. Similarly, expectation of x squared is not equal to expectation of x squared. Okay, so these are some conditions that you should remember. Okay, because these conditions will help you when you solve the questions related to the expectation. Now, some of the concepts of variance, that is, if x is a random variable, then variance of ax plus b. These are also important. A squared into variance of x. Okay, so I don't get into the proof because the proof is very easy. Okay, but you have to remember the concepts. Okay, because the time, if the time permits, I will show the proof, but remember the concept is important. Okay, now if b is equal to 0, then variance of ax is equal to a square variance of x. If a is equal to 0, then variance of b is equal to 0. Yes, and remember important point. Variance of constant is 0. Always remember. Variance of constant is 0, but expectation of a constant is expectation. Okay. An important point is that variance is independent of change of origin. Okay, variance is independent of the change of origin, but dependent on, but it is dependent on change of scale, because these questions can be asked in the CUET and JAM for the 1 mark stat, given that the variance, it is independent of the change of origin but independent of the change that it's discussed, because you have to remember that variance is independent of the change of origin but dependent on the change of scale. Now the last topic. Okay, after that I will conclude the class, that is covariance. So what is covariance? So if x and y are two random variables, the covariance between them are x, y. How will we write that? Like this. Y, okay. So when you open this, you will like this. You will get this. Xy minus and that is equal to expectation of xy minus expectation of x into expectation of y. Okay. Now, if x and y are independent, then expectation of xy, I have already told about in the properties of expectation that if it is independent, that it is equal to expectation of x into expectation of y. So covariance between x and y is equal to 0. So when x and y are independent, then the covariance between x and y are 0. Okay. So one important is covariance of ax into by. If some constant were associated with the random variable x and y, then it will equal to ab of covariance of xy. Nothing but take out the a and b and multiply it and then calculate the covariance of xy. You will get the required answer. Second is covariance of x plus a into y plus b. In that case, you have only calculated the covariance of xy, because when you take the expectation, it will become ab and then it will cancel out. Okay, Just prove exactly by this, you will get the answer. Okay. Third point, covariance of x minus x bar by sigma x, y minus y bar by sigma y. What is this? This is the normalization point. We normalize the data by minus it from its mean and divided by the standard deviation. By this, all the data come in a specific range. And this is equal to covariance of xy. Nothing but take out the lambda x and lambda y. Okay, just like constant because the standard deviation is constant, and x bar minus y bar is also constant because mean of both x and y are constant. So you will get this and divide by this one. Similarly, covariance of x plus y z, where z is the random variable, that will equal to z plus covariance of yz, where y z is random variable. Don't think that z is a constant and just keep it out, okay? Because z is also the random variable, okay? Now, covariance of ax plus by bx plus dy, that is equal to ac lambda square x plus bd lambda square y plus ad plus bc covariance of xy, okay? And I have also tell that if they are if they are independent, then covariance of x and y is equal to 0. Now the last important term is variance. One more formula is there, that is variance of x1 plus x2 is equal to variance of x1 plus variance of x2 plus 2 covariance of x1 x2, okay? If x1 and x2 is equal to 0, independent, not 0, independent, then covariance of x1 x2 is equal to 0, okay? Same for this, variance of x1 minus x2 is equal to variance of x1 plus variance of x2 minus 2 covariance of x1 x2. Same here, if x and x2 are independent, then it will equal to 0 and you will get only variance of x1 plus x2. Yeah. So of x1 minus x2 is also equal to okay. Now if we have more than 2, so general formula x1 plus 2 sum of all the covariance of xi xj, where I is equal to 1 to n, j is equal to 1 to n. So this is the general formula. Same here, if x1 and x2 are all the x's are independent, then this term will be equal to 0 if all xi's are independent. So by this I conclude my class. Sorry, the class is quite large, but the time is not very much in our hand. That's why I have completed all the probability measures topic today itself. Okay, so thank you for learning, and okay, so I conclude my class. Thank you.